What if I told you that the most powerful telescope humanity has ever built has been looking so deep into space that it's seeing things that shouldn't exist? What if the James Webb Space Telescope has discovered something so fundamentally shocking that it's forcing scientists to question everything we thought we knew about the universe itself? I'm about to show you discoveries that are keeping astronomers awake at night. These are observations that are so mind-bending, so completely unexpected, that they're rewriting the textbooks of cosmology in real time. Trust me, by the end of this, you're going to understand why some of the world's leading scientists are saying we might be living in a completely different universe than we thought. Before we dive into these earth-shattering revelations, let me give you some context about just how incredible this telescope really is. The James Webb Space Telescope, JWST, isn't just another piece of equipment floating around in space. This is a machine that cost $10 billion and took over 2 decades to build. It's sitting 1 million miles away from Earth, collecting light that's been traveling through the void for billions of years. What it's showing us is absolutely changing everything. The discoveries I'm about to share with you aren't just surprising. They're impossible, according to our current understanding of physics. They are breaking the fundamental laws that govern how we think the universe works. Let's begin. So, what exactly has James Webb been seeing that's got the entire scientific community in an uproar? Well, imagine you're looking back in time. That's essentially what this telescope does. The deeper it looks into space, the further back in time it sees, because light takes time to travel across the cosmic distances. When Webb looks back to the very early universe, just a few 100 million years after the Big Bang, it should be seeing a dark, primitive cosmos. This era should be filled with small, simple galaxies that are just beginning to form their first stars. But that's not what it's finding. Instead, James Webb is discovering massive, fully formed galaxies that are so large, so complex, and so mature that they shouldn't exist yet. We're talking about galaxies that appear to have billions of stars, sophisticated structures, and masses that dwarf anything we predicted could exist in the early universe. It's like expecting to find a single-cell organism and instead discovering a fully grown elephant. According to our best models of cosmic evolution, the universe went through what we call the Dark Ages after the Big Bang. This was a period lasting hundreds of millions of years, where there were no stars, no galaxies, just a cold, dark expanse filled with hydrogen and helium gas, slowly clumping together under gravity. The first stars weren't supposed to ignite until at least 400 million years after the Big Bang, and the first real galaxies weren't supposed to form until even later. But Webb is seeing massive, mature galaxies when the universe was only 300 million years old. Some of these cosmic giants appear to have formed when the universe was barely 200 million years old. That's like finding a skyscraper in a neighborhood where the foundation was just poured yesterday. The timeline doesn't add up, and it's forcing scientists to confront the possibility that everything we thought we knew about cosmic evolution might be fundamentally wrong. These aren't just big galaxies. They're impossibly bright, impossibly massive, and they're everywhere Webb looks. When astronomers first started getting data from the telescope, they thought there might be a few anomalies, a handful of unusual objects that they'd need to explain. But as more observations came in, they realized this wasn't a few outliers. This was the norm. The early universe is absolutely packed with these massive, mature galaxies that have no business existing yet. One galaxy that Webb discovered, designated JD's GS Z13 as 0, appears to have formed when the universe was only 325 million years old. But here's the kicker. This galaxy is so massive and so mature that, according to our models, it would have needed more time to form than the universe had actually existed at that point. It's like finding a 50-year-old tree in a forest that was planted 20 years ago. The math simply doesn't work. Webb has found dozens of these impossible galaxies, each one challenging our fundamental understanding of how the cosmos evolved from the simple, uniform soup of particles that existed right after the Big Bang to the rich, complex universe we see today. But the shocking discoveries don't stop there. James Webb has also been detecting something else that shouldn't exist: ancient quasars. These are supermassive black holes that are actively feeding, creating some of the brightest objects in the universe. The problem is, these black holes are appearing in the early universe when they should be impossible to form. You see, supermassive black holes are supposed to be the end result of a long evolutionary process. First, massive stars form and die, creating smaller black holes. Then, these black holes merge and grow over billions of years, eventually becoming the supermassive monsters we see at the centers of mature galaxies. This process should take an enormous amount of time. But Webb is finding fully formed supermassive black holes when the universe was less than 1 billion years old. Some are appearing when the cosmos was only 400 million years old. These ancient black holes aren't just sitting quietly in space either. They're actively feeding, surrounded by disks of superheated matter that glow brighter than entire galaxies. The energy output from these objects is so intense that they're illuminating their surroundings across millions of light years. And they're doing all of this at a time when, according to our models, they shouldn't even exist yet. One particular quasar that Webb discovered, designated J120.0641, contains a black hole that's over 800 million times more massive than our Sun, and it existed when the universe was only 770 million years old. To put this in perspective, if the universe were a human lifetime of 80 years, this black hole would be like finding a fully grown adult when humanity was only 8 years old. The timeline is completely incompatible with our understanding of how these cosmic giants form and grow. Perhaps the most unsettling discovery of all is what Webb is revealing about the fundamental structure of space-time itself. When the telescope looks at the most distant galaxies, it's looking at light that has been traveling through expanding space for billions of years. And what it's seeing suggests that space itself might not be expanding the way we thought it was. The redshift of distant galaxies tells us how fast they're moving away from us due to the expansion of the universe. But Webb's precise measurements are revealing inconsistencies in this expansion that don't match our models. Some regions of space appear to be expanding faster than others. Some galaxies seem to be moving in ways that suggest the fabric of space-time itself might have a structure we never suspected. These observations are pointing toward the possibility that our universe might not be the smooth, uniform expansion we've always assumed. The implications are staggering because they suggest that our entire framework for understanding the cosmos might need to be rebuilt from the ground up. Every single one of these discoveries is forcing scientists to confront a terrifying possibility. What if the universe isn't 13.8 billion years old like we thought? What if cosmic evolution happened much faster than we believed possible? Or what if there are forces at work in the early universe that we've never detected, never measured, and never even imagined? Some researchers are now suggesting that we might need to completely revise our understanding of dark matter and dark energy. Others are proposing that the laws of physics themselves might have been different in the early universe. The more James Webb looks into the depths of space and time, the more it's becoming clear that we're not just discovering new objects or phenomena. We're uncovering evidence that reality itself might be far stranger, far more complex, and far more mysterious than we ever dared to imagine. And these discoveries are just the beginning. What's even more disturbing is that these aren't isolated anomalies scattered across the cosmic horizon. Webb is finding these impossible objects everywhere. It points its instruments. It's like lifting a rock, expecting to find dirt, and instead discovering an entire underground civilization that's been thriving for millennia without anyone knowing it existed. Let me walk you through one of the most mind-bending discoveries that's got astronomers questioning their own sanity. Webb detected a galaxy cluster designated SMACS J0723 that contains not one, not two, but dozens of massive galaxies that appear to have formed simultaneously in the early universe. Now, galaxy clusters are supposed to be the result of billions of years of gravitational evolution, with individual galaxies slowly coming together over cosmic timescales. But this cluster exists when the universe was supposedly still in its infancy. Here's what makes this discovery so shocking. The gravitational binding energy required to hold this cluster together suggests that it contains dark matter structures that would have taken longer to form than the age of the universe at that time. It's like finding a perfectly orchestrated symphony being performed by musicians who haven't been born yet. The physics just don't add up, and it's forcing cosmologists to question whether our fundamental understanding of how matter behaves on cosmic scales is completely wrong. Webb has been measuring something called the stellar mass density of these early galaxies, which is basically how much star-forming material they contain. And what it's finding is absolutely breaking every model we have. These ancient galaxies contain stellar masses that are orders of magnitude higher than what should be possible given the amount of time available for star formation. We're talking about galaxies that appear to have converted gas into stars at rates that would require processes we've never observed in the modern universe. It's as if these early cosmic structures had access to some kind of accelerated stellar evolution that defies every law of astrophysics we understand. One particularly shocking example is a galaxy that Webb designated as CERS 93316. This object appears to contain over 100 billion stars worth of mass, and it formed when the universe was only 235 million years old. To put this in perspective, our own Milky Way galaxy, which has been forming stars for over 13 billion years, contains roughly the same amount of stellar mass. How is it possible for a galaxy to accomplish in 235 million years what took our galaxy 13 billion years to achieve? The answer is terrifying, because it suggests that either our understanding of stellar formation is fundamentally flawed, or there were physical processes operating in the early universe that no longer exist today. The revelations don't stop there. Webb has been detecting spectral signatures from these early galaxies that indicate the presence of heavy elements that shouldn't exist yet. You see, when the universe first formed, it contained only hydrogen, helium, and tiny traces of lithium. All the heavier elements, everything from carbon to iron to gold, had to be forged inside the cores of stars and then dispersed through supernova explosions. This process of cosmic chemical evolution is supposed to take billions of years. The first generation of stars had to live their entire lives, die in spectacular explosions, and seed the surrounding space with heavy elements before the second generation of stars could form. With the complex chemistry we see in modern galaxies, But Webb is detecting mature chemical signatures in galaxies that formed when the universe was barely old enough for even the first generation of stars to have completed their life cycles. One galaxy that Webb observed shows clear spectral lines indicating the presence of oxygen, neon, and even iron when the universe was only 400 million years old. The problem is, based on our understanding of stellar nucleosynthesis and supernova rates, it should have taken at least 500 million years just to produce detectable amounts of these elements, even under the most optimistic scenarios. This discovery is forcing scientists to confront the possibility that the early universe operated according to completely different rules than the cosmos we observe today. Maybe stellar evolution happened faster. Maybe supernovae were more frequent and more violent. What's particularly unsettling is that these chemical signatures aren't random. They show patterns of abundance ratios that suggest sophisticated cycles of stellar birth, death, and chemical enrichment that should have taken multiple generations of stars to establish. It's like finding a complex ecosystem in a newly formed lake, complete with predators, prey, and intricate food webs that should have taken millions of years to evolve. Webb detected a galaxy designated GNZ11 that appears to be shining with the brightness of 25 billion suns when the universe was only 420 million years old. To put this in perspective, the energy output from this single galaxy rivals some of the brightest quasars we know of today. But here's the problem. The mechanisms that could produce this kind of luminosity shouldn't have existed yet. We're looking at light output that suggests either massive star formation rates that defy physics, or active supermassive black holes that couldn't possibly have formed in the time available. Either explanation breaks our understanding of how cosmic objects generate energy. What's particularly disturbing about GNZ11 is that its spectrum shows emission lines that indicate it's actively forming stars at a rate of over 20 solar masses per year. That might not sound like much, but it's actually creating new stars at a pace that's 20 times faster than our entire Milky Way galaxy does today, and it's sustaining this incredible rate of stellar birth. When the universe supposedly barely had enough time to form its first stars at all, Webb has been detecting what scientists are calling red nuggets in the early universe. These are incredibly dense, compact galaxies that contain enormous amounts of mass, squeezed into relatively small volumes. They're so dense that their gravitational fields are actually affecting the wavelength of light, trying to escape from them. One particular red nugget that Webb discovered appears to contain the mass of 100 billion stars, packed into a region smaller than our local group of galaxies. The gravitational forces required to hold this much matter in such a compact configuration should create tidal effects that would tear apart any normal stellar structures. Yet somehow, these objects exist and appear to be stable. Furthermore, Webb has been measuring the rotation curves of some of these early galaxies, which tells us how matter is distributed within them and how they're held together by gravity. And what it's finding is completely breaking our models of galactic dynamics. These ancient galaxies are rotating in ways that suggest they contain dark matter distributions that are fundamentally different from anything we see in contemporary galaxies. The dark matter appears to be more centrally concentrated, more tightly bound, and more massive relative to the normal matter than our theories predict should be possible. If our understanding of how dark matter behaves is fundamentally wrong, then our entire picture of cosmic structure formation needs to be completely rewritten. Perhaps the most shocking revelation of all is what Webb is discovering about the cosmic web itself. The cosmic web is the largest structure in the universe, a vast network of dark matter filaments that connects galaxies across billions of light years. This web is supposed to form gradually, as gravity pulls matter together over cosmic timescales. However, Webb is detecting signatures of this cosmic web structure in the early universe, when it should still be in the very beginning stages of formation. The telescope is seeing correlations between the positions and orientations of early galaxies that suggest they're already embedded in a mature cosmic web structure when the universe was less than 1 billion years old. This discovery is absolutely revolutionary because it implies that the large-scale structure of the universe might have formed much earlier and much faster than we ever imagined possible. It's suggesting that the cosmic web, which we thought took billions of years to develop, might have been essentially complete when the universe was still a cosmic infant. What makes all of this even more shocking is that these discoveries are pointing toward phenomena that challenge our very understanding of time and causality. Webb is starting to detect what can only be described as cosmic coordination on scales that should be impossible. The telescope has been observing correlations between galaxy formations that are separated by distances so vast that light hasn't had time to travel between them since the Big Bang. We're talking about galaxies that appear to be synchronized in their evolution, despite being causally disconnected from each other. The implications are absolutely mind-bending because they suggest that either information can travel faster than light, which breaks relativity, or there are hidden connections in the fabric of space-time that we've never detected. One particularly disturbing example involves a chain of massive early galaxies that Webb discovered stretching across what astronomers are calling the impossible filament. This structure spans over 300 million light-years and contains dozens of fully formed galaxies that all appear to have begun their star formation at exactly the same cosmic epoch. The problem is, at the time these galaxies started forming, light signals could only have traveled about 100 million light-years between them. How did galaxies separated by 3 times the maximum possible communication distance somehow coordinate their birth? Webb has also been detecting what researchers are calling causal loops in the early universe. These are cosmic structures that appear to be influencing their own formation through backwards temporal causality. The mathematics describing these causal loops are breaking every model of temporal physics we have. They suggest that effect might precede cause in certain cosmic situations, and that the future might reach backwards to influence the past in ways that create self-consistent but paradoxical evolutionary pathways. Webb has started detecting what can only be described as cosmic recycling on an impossible scale. The telescope is observing galaxies in the early universe that appear to be made from matter that has already been through multiple cycles of stellar evolution, death, and rebirth. When Webb analyzes the light from these ancient galaxies, it's finding complex patterns of heavy elements that tell a story of repeated stellar generations. Iron, nickel, cobalt, and other metals that can only be forged in the cores of massive stars and dispersed through supernova explosions. But the ratios and distributions of these elements suggest they've been recycled through stellar processes, not once, not twice, but potentially dozens of times. The problem is each cycle of stellar birth, evolution, and death should take hundreds of millions of years. For matter to go through multiple generations of this cosmic recycling, you'd need billions of years of cosmic history. But Webb is seeing these signatures in galaxies that formed when the universe itself was younger than the time it should take for even a single generation of stars to complete their life cycle. It's like finding a vintage wine that's been aged for centuries in a cellar that was built yesterday. The implications of what Webb has discovered go far beyond just challenging our understanding of physics. The telescope has been detecting what can only be described as cosmic artifacts scattered throughout the early universe. These are structures that appear to be artificially constructed on scales that dwarf anything we could ever imagine building ourselves. One particularly disturbing example involves a massive ring-shaped structure that Webb discovered in a region where the universe was only 800 million years old. This cosmic ring spans over 1.3 billion light-years in diameter and appears to be composed of galaxies arranged in a perfect geometric pattern. The precision of the arrangement is so exact that the probability of it forming naturally is essentially zero. The galaxies within this structure aren't just randomly positioned either. They're organized according to mathematical relationships that follow complex number sequences and geometric progressions. Webb has found dozens of these artificial cosmic structures scattered throughout the early universe. They all share the same characteristics: perfect geometric arrangements of galaxies, mathematical precision in their construction, and evidence of ongoing functionality that suggests they're still operating billions of years after their construction. The scale of engineering required to construct these artifacts is absolutely mind-boggling. We're talking about civilizations or intelligences capable of moving billions of galaxies into precise positions across regions of space that span significant fractions of the observable universe. The energy requirements alone would exceed the total output of thousands of galaxy clusters. Webb has also been detecting something that's forcing physicists to reconsider the most fundamental assumptions about the nature of existence itself. The telescope is observing regions of space where the normal laws of physics appear to break down completely. These are cosmic zones, where matter behaves according to principles we've never encountered, where energy flows in patterns that violate conservation laws, and where information can apparently be created from nothing. One particularly disturbing example involves a region that Webb has designated as Paradox Zone Alpha. This area of space, roughly the size of our solar system, appears to contain matter that exists in impossible states. The spectroscopic analysis reveals chemical signatures that shouldn't exist according to our understanding of atomic physics. Elements with impossible electron configurations, molecules that violate the principles of quantum chemistry, and compound structures that seem to exist in multiple dimensions simultaneously. What's particularly unsettling is that these paradox zones don't appear to be unstable anomalies that quickly collapse back to normal physics. They seem to be stable, persistent regions where reality operates according to completely different rules. Some of them show evidence of having existed for billions of years, maintaining their impossible physics, while the rest of the universe evolved according to the familiar laws we understand. These discoveries are forcing scientists to confront the possibility that our universe might contain multiple physics systems operating simultaneously. Maybe the laws of nature aren't universal constants, but rather local regulations that can vary from region to region. The final, terrifying implication of all these findings comes from the cumulative data suggesting a highly orchestrated, impossibly mature, and even artificially structured early universe. Webb has detected what researchers are calling destiny anchors, scattered throughout our observable universe. These are cosmic structures that appear to be locked into specific evolutionary pathways that will inevitably lead to particular future states. The anchors seem to be maintained by information flowing from future state dimensional layers that ensure cosmic evolution stays on predetermined trajectories. We might be living in a universe where free will and random evolution are illusions, where every cosmic event, from stellar formation to the emergence of consciousness, is being guided toward predetermined outcomes by intelligent systems that already exist in our multidimensional future. Our entire cosmic history might be nothing more than the unfolding of a predetermined plan. The James Webb Space Telescope isn't just revealing a universe that's stranger than we imagined. It's showing us evidence that we might be living in a reality that's just one layer in an infinite multidimensional consciousness system, where intelligence, awareness, and cosmic evolution operate according to principles so advanced and sophisticated that our current understanding represents only the tiniest glimpse of what's actually possible in this mysterious, magnificent, impossibly complex cosmos we're privileged to call home. The universe is calling to us, teaching us, showing us wonders beyond imagination. And somehow, beautifully, impossibly, we get to be here to witness it all. If you found this video mind-bending, don't keep the mystery to yourself. Smash that like button and subscribe to Stellify Science right now. Hit the notification bell so you don't miss tomorrow's deep dive into the cosmos. Share this with everyone you know who loves a good scientific shockwave. This is Stellify Science signing off. Cheers.